Welcome back to R for Economics. In this video, we'll be talking about the artificial neural net in R, which is the neural net package. So we bring in our library, R sample. These are for our data that we want to examine in this. And we're going to be using the same data that we used for decision trees and random forests, which is the SPAM data set first. And SPAM being yes or no, and then you can see that we get a yes or a no, depending on what we're 0, no, 1, yes. So we can see that 39% of the data is a yes. So we're going to sample this using the end function into a train and a testing data set. Now, one of the things about neural nets is that they work best if you actually scale your data between 0 and 1, or scale them by the normal distribution or something which will center them at 0. Center them at 0 or center them at 0.5 seems to help improve the estimation techniques. And because the scaling is ordinal, it will preserve the order, so it actually has little effect on the overall result as long as you can convert it. So we're going to scale it by the min and the max of the big data set. Our scaled data, you can look at the summary for these, summary of the scaled. If you go through these and transfer them from one to the other, you'll see that they're nearly identical. And now we can use the end that we generated earlier to get a train underscore and a test underscore. And if we wanted to, we could examine all of these summaries to make sure that there's nothing has been lost. But you can see that the yes/no is not changed because they are already in a yes/no state. This neural net function will actually take a little bit of time to run, so I'll be pausing immediately afterwards, and then once it's done, I will come back. Okay. So I'm running it, and I'll see you just in a moment. And we're back. That took about 9 minutes. It's a much more complicated model than the other one, so it takes a little while. Now, here we can see that we've used the training underscore data set, and we should have 5 hidden units, and then followed by 3 hidden units when we plot it. And we can see this in our plot here, where we have 1, 2, 3, 4, 5 hidden units followed by 3, and then our yes, no at the end. And then we have constants at each point in time. And we can, if we go through this, we can see what the relative weights are for each of these as we go through. If we plot just the best one, this is the best neural net that we have, and it's, you know, how many steps in the error is going to be the lowest. If we want to look at our results, we can see again that our results are based on being 0.5, deciding whether it's going to be no on the left and yes on the right. And we can look at a summary of these, and we can see that we have a mean of 0.39, which is close to what we would usually expect. And if we look at our second one, because we did 2, we actually did 5 repeats. And then we can see that we have 5 repeats, and they have this format for each of them. And we can look at each of those lists. Now let's do a prediction. So we're going to compute our predicted values. We can look at the summary of these, and we can see that the mean is 0.4. And if we do a histogram of this, we can see what our predictions are. And it seems fairly similar to what we had for our test, for our training. Now, here we can predict and say 0.5 is going to be our cutoff. So if it's greater than 0.5, it's going to be yes, and a no for less than. And likewise for our test data. And then putting these into our matrix, we can see what kind of gain we're going to get from each of these and our misclassification rate. And we can see that our misclassification rate is 12.1%, which is very similar to what we had in our random forest example. Now let's move on to our regression, because it's not just a classification that you can do this with, you can actually do it with regression. So we're going to set our seed, generate our trainings data set. Here we're going to apply our data set in order to get generate our data. We need these underscored. BR is just a combination of both our training and our test data set. And we need to find the maximum and the minimums of that in order to do our scaling. So our scaled train and our scaled test can be given here, and based on the centering at the minimum, and then max and mins give us our scale, and it's down between 0 and 1. So now we can run our neural net. Here we're going to, because we have 80 variables that we're going to be using as inputs, our sale price, what we're going to do is use a much larger hidden layer to begin with, and then that's going to drop very quickly. And we're just going to use 1 repetition this time, and then our maximum number of steps that we're going to use, we're going to make that nice and large, so we've got lots of room. Okay, again, I'm going to pause the video and then come back once it's completed. Welcome back. So we've now had it run. It ran for about 3 minutes and is now completed. So we can look at the plot of our neural net. And I'm just going to share a different screen. And here we can see that we have these 80 categories going down to 20 to 5, and then our sale price. Now we can also generate the histogram of this. Sorry, I'm just trying to get this to come into our environment here. There's our histogram. So we can see the histogram of our results. So these are our sales price distribution, our frequency. That is between 0 and 1, as we would expect. And then we have our training sales price, and we can see that that's very similar in pattern between the two. Now, we can also get a summary of this result, and we see that the mean is about the same, and of course the maximum and minimum are very, very close together as well. Now, doing our prediction, we can get our summary of our predictions. We can see that we've exceeded the bounds of the bottom and exceeded the bounds of the top by a little bit, but our transformation should be robust to this. Now, we can plot these of our predicted times our test underscore sales price, and we can see that the overall direction, and these should be 1-to-1, so a 45-degree line in red should cover most of the action that's going on between these two with random errors. And what do we get as a random error? We get a 5% based on these predictions here. Now, if we want, we can actually convert these back so they're not scaled between 0 and 1. And when we do that, we just need to multiply by our scaling factor and then add our minimum back in. So when we do this, we can see we get 37,000. Now, if we remember, our random forest was able to give us 25,000. So this is not as good as our random forest, but it's at least giving us a different interpretation. And we can plot those and look at those, and we can see that the overall image didn't change. Now, there are lots of other features in artificial neural nets, and those are not covered here, but you could cover those on your own. This is a primer to get you started. Great, and we'll see you in the next video.